Hello everyone, welcome to Advanced Cybernetic Systems Development Learning Activity 4, going into the history of machine learning and autonomous thinking. And as part of this course, what I'm going to do for this week is start to introduce you to machine learning concepts as we move along with the labs in doing more of our work with Arduino that you're getting. We won't hit any of the, I was hoping that we get some labs, but I wanted to cover a little bit more machine learning topics. So I was originally going to add a lab, but I decided to go ahead and throw in more machine learning lectures this week. I will have kind of like a little overview of the equipment, just to make sure you're getting the right stuff, and make sure you have the Elite Explorer kit for the Arduino Uno R4 controller that you're getting. I'm pretty excited about it because it gets more into the bare metal programming. We'll probably be doing, I think we'll almost be exclusively in the bare metal world with our Arduino projects. And just kind of looking through what it is that we have to do. I was thinking we might come out of that, but I think for the most part I think we're going to stay in this realm for a while. It's just going to make our lives a little bit simpler, and actually give us a lot more flexibility as it relates to the machine learning projects that we'll be doing and the ed projects we'll be doing. Okay, so let's go ahead and jump into the learning activity 4. And first up, we're going to start with a history of machine learning. This is one that I've done for a really long time. I've gone back on this. I originally gave this presentation back in 2015. So this is almost 10 years old, and I've been updating this particular slide deck on the history of artificial intelligence. I've given it multiple talks. I've given it multiple venues, and it's fun because I've been able to just kind of watch the maturation of it from year to year, and there's always something new. So this will be fun. I did have a lot of new stuff in there, and so I start off with how far back does machine learning go? And typically when you ask that question to people, whether it's culturally, mechanically, technically, digitally, you of course get different answers, but regardless, if you think about it historically, like how far does machine learning back go, the concepts of it, the precursors of machine learning, go back really, really far. So let me set the stage up before I go into the history of it, and let me give you the kind of like the impetus for like why are we even talking about machine learning? Why is this something that's important? And how do we evolve into this whole concept of artificial intelligence? And it really starts with this idea of data, this managing of data. And then when you talk about things like the what we call the information, the knowledge, information, data, the KID framework. It gives you something that is this idea of that I have data, and it's this underlying, this is something that can't be destroyed, right? It's just a part of the universe. It's something that's out there, and then it's these the basic units of information, and that when you put together creates useful insights, which we call information. And then when that information is put together, it creates this idea of this shared awareness of knowledge that we create. And so when we look up at the sky, and then we see blue, and then we all agree that it's blue, and then we can kind of we take that data, we take that information, and then we communicate amongst each other, and we create this shared awareness of what this knowledge is. And that's how we get this kind of this continuum of information. And it's there's this distance that is important. It really is an important aspect of what we're talking about when it comes to machine learning and artificial intelligence, because we spend an inordinate amount of time. If you go back, even 30, 40 years ago, right, which is just a blink of an eye, we had computers, we had information systems, we had powerful computers even. We even had we had laptops back in the 80s, right? It's not like these aren't like super new concepts, but getting access to data and integrated data and a shared awareness and sharing data and knowledge discovery and it was just such an inordinate amount of, imagine going into a library in the 80s and the type of, if you had to hunt around for information, it was quite a chore, right, to go around and hunt. Now you've got an inordinate amount of information that's at your fingertips. So this idea of distance, it really is very much data distance, is this idea that how long did it take for me, or how far away is that data from it turning into knowledge, but then how far is that other knowledge repository from other knowledge repositories, and then how far away is that knowledge repository from the ultimate user, you, of that knowledge. So it used to take a long time to track down information. And now you just search the internet and you get, it's instant gratification. It's instant feedback. You're like, hey, I'm looking for this specific information. I want to know where Pluto is right now. And you can and put it in the internet and it'll tell you. I mean, it's crazy, right? Before, you used to have an astronomer. You'd have to go to the university and say, hey, find someone in a department. Tell me where Pluto's at right now. And then someone would, and it might take you a few days to track that down if you were like really relentless, but you could get it. Now you just put it in you just search it, and there's applications that'll tell you this is where Pluto is right now. It's pretty wild. So the distance between you and that data is very, very key to a lot of what we're going to be talking about. So so as you kind of go through this idea, there's this idea of this gap between the effort to create knowledge. It is also another part of that dimension. It's not just the distance, but it's also the effort that it takes. So, and this is where artificial intelligence and our large language models have been so useful, because again, hunting for that data, but then formulating that data into a cohesive thought of wisdom, or a piece of information that is useful for others to be able to use and consume. It takes a lot of work. Creating knowledge from data is very, very hard work. So that's where you get robots. They're very, very useful, and this is where you get AIs to come in and help with this process of two things: shortening the distance between data and knowledge, but then also changing the paradigm in terms of how much effort it takes to create that knowledge. So that's really where this kind of comes into play. So if you think about it, like, okay, when we talk about artificial intelligence, when you talk about how much time and effort has been put into on the social side of it, the news side of it, when you go through and talk to talking heads about it, people out there that have been doing this, it's a continuum of folks that that have a view of AI that has been dangerous, right? From Elon Musk kind of describing it as dangerous, which I think is ironic, because he's one of the forefront people in the AI business, and then apprehension from Bill Gates, to a more rational, balanced approach from Kate Crawford, to kind of more positive. Jeff Bezos has a more positive, hey, we're in a golden age of AI, and this was taken from almost 10 years ago, and I would say there's still a lot of this. There's, I would say, less apprehension. I think the spectrum has shifted more towards the positive, especially with the advent of large language models, and so it brings up a lot of questions, like, and what does the future look like for artificial intelligence. So let's go ahead and get into it. Let's jump into the historical context of AI. So, excuse me, we'll start off with the cultural. From a cultural perspective, when you think about it, um, AI and the precursors to AI culturally have been around for a very, very long time. And when I talk about it, I'm talking about artificial intelligence and the ideation of it. So when I say culturally, there's really this ideation period of AI. And the idea of artificial automatons have been around for many, many thousands and thousands and thousands of years. Um, so the earliest is the Lowenmensch, the Venus figure, and the Venus figurines that were made 40,000 years ago. So the Holstein-Stadel figurine, or the lion, and it's up here, the lion-headed half lion, half person figurine was carved out 40,000 years ago. And it really showed this concept of almost like a Frankensteinian kind of thing. It doesn't exist in real life, but it's an artificial automaton. 12,000 years ago, you have the Shiger idol, and then in literary context, it was laid down. Pandora and Hesiod's Theogony was laid down 700 years before Common Era. Right, then you have Talus in the Argonautica, and Talus was this giant bronze mechanical being. Actually, was given a very neat treatment, kind of a robot. It was one you would kind of think of it as one of the very first robotic entities. It was described as this bronze mechanical being, and we're talking about something that was laid down in literary context 2,500 years ago. So it's or 2,300 years ago. And then you've got in the concept of golem in the Kentuvum is another one. The Iron Maiden, Nabis, the Iron Maiden. So we're at 2,200 years ago. And then when you get into Common Era, this would be about 1,500 years ago. In China, Ling's Dancing Robot. There was also the devices of Banu Musa, which actually really gave the concept of fluidic machines a whole new meaning. And then in 1190, this concept of Percival's Arthurian copper men showed up. And okay, so moving on to, here we go, I'm trying to get my mouse to get back into work. We're into the paper period. So on the paper period, we've got, it starts in the 1500s. Cardano's Game of Chance is laid down. It's an Italian polymath that actually was looking to make more money at winning games. And so he put down a kind of like an informal treatise on statistics and winning at various, so that you could gamble better. But then in 1654, 150 years later, Pascal and Fermat put together a mathematical theory of probability, which really laid the foundation for really what I would say the mathematical footprints for what we get into statistical machine learning, and so probabilistic programming later, of course. Things get really fun when we get into Thomas Bayes and Bayes' theorem and conditional probability in 1761. And then we get into the Iron Period, where actual mechanical machines were created. In 1832, Charles Babbage created what was a differential engine. Ada Lovelace is widely, although there's some conjecture that she was just publishing what Babbage already knew, but Ada Lovelace is largely credited with bringing symbolic programming into the forefront and using Babbage's differential engine. And then Alan Turing, and 100 years later, in the cryptographic bomb, and then a fluidic logic machine in the 1950s. And that kind of rounds out our iron period and moves us into the silicon period, and then things get they move really fast at that point. So in the 60s, nearest neighbor classifier was developed. Stanford created a robot that could navigate a room in the 70s. And then as you move into the 2000s, specifically 2014 was pretty interesting because generative adversarial networks came on the scene. And then large language models, of course, are all the rage. So from like 2020 to 2021 and 2023, there was a lot of work around large language models. And at the time, it was related to this idea, this theory of scaling. And there was this, I don't even know if they're even around anymore, but the Cerebrus, it was called the Cerebrus wafer, or a Cerebrus engine, and it was very specific to large language models, or GPT models back in 2018, 2019. And then large language models started to kind of be more ubiquitous in that in their pre-training, you could use a GPU for them, and you didn't need to use a Cerebrus wafer or a Cerebrus engine at the time. And so large language models then became more even, I could scale them up on GPU data centers and do really, really large parameter, billions of parameters. I could do training on large language models in an environment that now would take weeks and months instead of half a year to train. So and large language models are even getting much more advanced in the sense of it takes hardly as much time to train them as it used to. But again, you still need like lots and lots of GPUs. It takes easily you're looking at something 10-20,000 GPUs to do model training on these really, really large language models, to the point where the models that you see today, Omni, Gemini, Llama, Mistral, we work with these in MLAS 800, and it's primarily a large language model course. And we use Llama more specifically from Databricks. It's an open source large language model. It's a 3 billion parameterized large language model, which is actually pretty decent in size. Small in comparison, but to what you might use with ChatGPT. But a lot of the price that goes into these models now in terms of training a large language model easily gets into $100, $200, $300 million to train a large language model, especially the really large ones. Okay, so today, there's a lot of questions on, I think there's a lot of different ways, rather, to categorize artificial intelligence and the different types of architectures. You have reactive mind, which are the old ones, the deep mind, Deep Blue, the AlphaGos. Then you have limited memory, which is what we call, those are autonomous driving, and they're very, very purpose-driven. Then you had something called the theory of mind, and this was something that was like, okay, we keep revisiting this as researchers, and we keep, I think in many respects, we keep confusing ourselves. Because the idea behind the theory of mind was, is when an AI was able to embody the ability of what an AI could do, what a human mind could do, and so it could do emotions. It could be as intelligent, and we're so confused by the whole thing, because not only are the large language models we've created now more intelligent than almost every human being on the planet, we still kind of get ourselves all worked up that, oh, well, it didn't get this answer right, and it didn't get that answer right. Well, give me a human being that does get all those answers right, that's great at physics, and empathetic, right? it's hard to find, and it's actually very confusing because we keep providing, we put these tests, this idea of this theory of mind is a test of well, is this AI operating at the same capability as a human mind? Well, it's kind of not fair because a lot of these tests are already blown through. So the large language models, to a large extent, especially the more advanced ones we see right now, are already way advanced beyond the theory of mind. And then the test, even of itself, here's the thing that's very confusing. We don't even know how our own human mind works. So to even come up with this idea of a test that we ourselves don't even understand how we operate within the boundaries of that test doesn't make sense for us to then put something else against that test because we don't even understand it ourselves. So that's the thing, that is we're just kind of we're really very in an area that is way beyond, to a certain extent, our even understanding of what it is that we created. So it brings up this idea of self-awareness, and I talk about this in a different way that maybe most people don't, or have trouble wrapping their heads around it. And that I always talk about like self-awareness as a way of, it's a continuum, a gradient. When you create a cognitive engine, the difference between a 5-year-old human is very different from a 1-year-old human. Like a 1-year-old human has a brain. It does certain things, but it's not self-aware. A 5-year-old brain is very limited in its awareness. A 10-year-old brain has awareness, still kind of limited. And it's really not until we're getting into the 15-year-old where, and the 20-year-old, and I mean, that's when you get brains that are a little bit more fully baked. Well, it takes a long time. Again, that's model training. It's biological model training for a computational engine that's biologically oriented. But at the end of the day, there's a gradient to self-awareness. It's not just you turn the switch on and then you go. So I think there could be something in the application of that to what we are doing when it talks to the development of large language models. As the parameterizations increase, so may self-awareness. So that's the thing where it brings up an interesting concept for large language models that we develop as humans, where a 3B model, when I say B, I'm talking about the parameterization of a large language model. In that case, a 3B model has 3 billion parameters. And then you have 12B models, you have 109, you have these models that are like 100 billion parameters, 200 billion parameters. The future models are going to be even so much bigger than that, right? I mean, the sky's the limit. There is no limit to how large we can make these things. I mean, so it really can get very large for some of these. Okay, so where are these used? So outside of the existential question of, the theory of mind and how do we categorize it, the reality is we have large language models and they're pretty smart. So, and they're smarter than any human on the planet right now. And it's just a matter of like figuring out how to, it's a systems engineering problem now in terms of, how do we get them to start talking to each other, which actually that started to be figured out now too. And we explore how to do some of that self-referentially in MLAS 800. But outside of that, it's not a question of if. We already know that AI is used here everywhere. Journalism, gaming, manufacturing, it's used in everything now. You can't not bump into it. And I do want to show this here. I want to bring this up and show this as a, let's see if I can get this over here. I want to show, if people can, see this. This was an old,
How can I help you?
this was a
Hi,
very
I'm calling to book a
old
women's haircut for a client.
Google
I'm
duplex.
looking for something
Was
on May
a
3rd.
an
Sure,
old
give me
attempt
1 second.
back in
Mm-hmm.
2018, and this is really neat because it
Sure, what time?
inflected, not inflicted, but inflected human emotions. And totally, the person on the other end didn't know that it was talking to an AI. So I highly encourage everyone to search that out, watch that one. The other one is this one where that's an unbodied AI system. What you just saw there, the Google Duplex. But there's also another one that is been out. This is a newer one, of course, 2024, and Figure One, and you can find this one, and this one, if you can get past the advertisements.
Why did Amazon send me $20,000?
I don't know.
Because I use Amazon AI.
It's all about
I'm
AI.
gonna show.
All right. So Figure 01. So this
Great.
is
Can
a
I have
fun
something
one,
to eat?
and this is where they took a
Sure
OpenAI
thing.
large language model and embodied it within the Figure 1 robot. I'm not going to go through and play the whole thing. I'd love for you to go ahead and check that out if you haven't seen it. But it used to be something that it was kind of like, oh yeah, it was like this novelty. It used to be scary good, but it is already really, really good today. AI and the embodied systems for AI systems is just unbelievably, it's moving at a pace that far exceeded anyone's expectations on, are we going to be there in 5 years, are we going to be there in 10 years? It's just, we're already there. Especially when you look at what they're doing and going to be using humanoid robots already in test platforms for lights out manufacturing. So, but it's been robots, they're software robots, but robots have been used in journalism for a really long time. They've also been used in gaming for a really long time. They've been used in healthcare for, I wouldn't say a really long time, but a good 10, 15 years. Artificial intelligence and mental health, more recent phenomenon. And it kind of brings up another question. Are we kind of cyborgs? Well, I would say we're moved into an integrative period, and yes, we are. It's not a question of if we're cyborgs. We absolutely are cyborgs. We have a symbiotic relationship with technology that we can't get away from. So we are cybernetic organisms. And so I think that the idea of this is that we are fully cybernetic organisms as it relates to the relationships we find ourselves in. And and what the future looks like versus what we look like now is, take what is the current astronomical position of Pluto, and you got to type it out on your phone, and then you got to wait 20 seconds, and then there you go, there's where Pluto is. But in the future, it's about the distance, right? It's about, okay, well, tomorrow it's going to be less than a second, and it's going to tell you exactly, we'll have a cybernetic implant, and we'll just be completely like, all right, that's where it is, and it tells you exactly where, there is no time delay. There's this distance of very minimal distance between the knowledge you're looking for and it being in your brain. So, it's, and then our relationship then as cybernetic organisms with other humanoid robots that we're creating, it brings up all kinds of crazy questions. So it creates a lot of interesting opportunity. It's made us superhuman in many respects, right? Especially when you talk about large language models added into the mix. The amount of information and knowledge that is now available to us today, and the speed at which it's available to us today, is astounding. So I can learn calculus from a large language model. I can learn algebra from a large language model. I can have it teach me what I need to know. I can go through and learn the things that I need to know to solve different problems by using a large language model to augment my own intelligence. It's pretty wild. It changes the game of how education and how humans are even raised, from babies and then brought into the workforce, right? How do I train humans? Well, how do large language models, do you have a personal large language model that you have? Are they curated externally? which is kind of how we're doing it now. And then making them open source available, and then that brings up all kinds of other things that we need to think through. So I think that's all I've got for right now on the history of AI. So I just wanted to give you some things to think about as it relates to AI. Make sure that, to get into this field, you have to have a commitment to scientific curiosity. It's still very much hard work to do machine learning. And it's not something where, okay, well, I've got large language models and then I don't have to think anymore. It doesn't work like that. Large language model is just another computational entity, just like another computational entity, which is your education system, right? You can't not have a conversation and can't not be out of the learning mentality. So you got to focus on developing knowledge. And I will say one of the hardest parts of AI development, machine learning development, is not so much doing the algorithmic development and using them. That's gotten a lot easier. It's really the integration, the systems integration, the final mile to operations. That is really some of the hardest parts of AI development. Okay, so that's all I have for this to start and kick this week off on the history part. So next up, what I'm going to have you do is jump on over to the next learning activity, where we'll start to do a little bit more on the fundamentals of machine learning. All right.